Melanie needs to cut a carpet with two angles that each measure 80 degrees and two angles measure each 100 degrees. Name the quadrilaterals that could be the shape of the carpet. So in my understanding, the number of quadrilaterals that can be shaped into the quadrant, this shape of the carpet, will be three different ones. And the first one is going to be an isosceles trapezoid. The second one's going to be, let me give you a little space. Second one I could draw is a rhombus. The third one I can think of is a parallelogram. Now, I do not have drawing space here, but I will try my best. An isosceles trapezoid would be like this. They look pretty nice. They're not drawn to scale, but an isosceles, and I can make it, since by definition of trapezoid, this side and this side are parallel. This angle right here can be 80, and sorry, not 80. It's bigger than the right angle, so it cannot be 80. It will actually be this angle right here will be 100. This smaller one will be 80, and 100 plus 80, when you add these two angles, they have to give you 180 since it's a straight line. By parallels, although I think this is for geometry, so it doesn't count. So this side would be, this angle would be 100, and this angle would be 80. It says two angles that each measure 80 and 100. So that would work for an isosceles triangle. Now a rhombus would be like so. And in this case, this side would be 100. This side would also be 100. This side would be 80. And this side will be 80. And it works since this side is going to be equal to this side. It's going to be equal to this side. It's going to be equal to that side. That's how the degrees work. And so it could also be a rhombus. And finally, a parallelogram is going to be exactly the same thing as a rhombus because every rhombus is also a parallelogram. So it would be exactly the same. And I could draw it out. Every rhombus is a parallelogram. So I can do a different type of parallelogram, maybe one that's a little bit longer. So I can do a parallelogram like so. It's a little bit different. And then this side can still be 100. This side could be 100. This side could be 80. And this side could be 80, satisfying our two angles each measuring 80 and two measures that each measure 100. Now these sides will not be the same exact length. The sides will now be a little bit different. This side could be equal to this side. Well, actually they have to since it's a parallelogram. This side could be equal to this side. Now by definition, a parallelogram has to have two sides that are parallel to each other. So this side could be parallel to that side, and then this side could be parallel to that side. That's my answer. A isosceles trapezoid, a rhombus, and a parallelogram.